Welcome. Today is your first time seeing this video. Please try to subscribe and share it to your friend. Here, what you're going to do today is limit of a sequence. And when we talk about the limit of sequence, we talked about how you can solve questions like this using the epsilon. Okay, what is the epsilon here? This is a symbol for the epsilon. It's a symbol for the epsilon. So you see here, I have my question and solution is already written here. The reason is that before you can even solve a question like this, you need to state this. It's a theory you need to state before you solve the question. And the theory says that given any epsilon greater than 0, there is it capital N equals N of epsilon greater than 0. And N greater than N, that's small n greater than capital N. Okay, let me take it this way. N greater than N, small n greater than capital N. Then we are saying that 1 over N will be less than 1 over capital N. Then the distance between the AN, which is the whole of this one, so always the AN is this, is minus L. You know, distance should always be in the whole, in the absolute, it should be positive. It's always less than epsilon. So we are just going to prove to see that even this is always less than what? Epsilon. Is that okay? And 2, this one, you know, if you use the normal proof, you will get this 2 because you need to divide both sides by the highest power of the numerator. Is that okay? All right, now let's look at how this one can be solved. So you realize that if I take this, which is 2n squared plus 1, all divided by n squared plus 3n, minus the L, which is the answer, we are saying that it should be less than epsilon. Okay, now what happens here is that let me solve this one. Find out LCM of this. If you find out LCM, you're going to get 2n squared plus 1 minus 2n squared plus 3n, and all divided by, this is supposed to be minus 6n, all is divided by n squared plus 3n. Okay, now what is going to happen here? This and that are the same, so they will cancel out, leaving 1 minus 6n. So here I have 1 minus 6n, and this is divided by n squared plus 3n. This is always less than epsilon, but you are still proving to see whether it will be less than epsilon. What happens here is that, please, you should pay attention to this thing because how it looks like sometimes you might not understand things, but there are theorems you need to follow them. Okay, so in this case, what I'm going to do is that let me go back to this. If I'm solving this one without having to prove using the epsilon and stuff, and I'm just solving it straight away, you know what I will do? What I'm going to do is that, like, if they ask me to solve this without saying that show that this limit is equal to this, and I'm to solve it straight away, all I need to do that, since n is approaching infinity, I'll just take 2n squared divided by n squared plus 1 over n squared, all divided by n squared plus 3n over n squared. I hope you know that. So that when you do that, you see this and that will go to 0, leaving 2. I mean, go to 1, leaving 2. This and that will still remain. This and that will be 1 plus this. This will give you 3 over n. But because n is approaching infinity, you see, when I put 1 over n squared, 1 over like 1,000 or 10,000 or whatever, when n is, let's say, 1 million, you see the 1 over 1 million will be approaching a very small number, so like 0.0001, which will be approaching 0. The same thing applies to this. So if that thing happens, you can say that this is 0, this is 0. So we have 2 over 1, which is 2. So if that is the case, here, that the same thing we are going to do here. But before I will do that, so if I do that, if the highest power, always we consider the numerator. So the highest power of the numerator is 1. Okay, so if I divide here by 1 over n, see that 1 over n, everything will go to 0, because like the explanation I'm giving. And if I divide here by n over n, I mean if I divide here by n, sorry, everything will go to 0. If I divide here by n, it will leave with 6. Then you have negative 6 over, if I divide here by n, I have n, plus if I divide here by n, I have 3. But I'm adding 3, which is an integer, to integer, so I will still get integer. Okay, so this should give me 6 over n. And you say that this, per what I stated here, 1 over n is less than 1 over capital N. So I can say that this 6 over n is less than 6 over capital N, which you know that they are all less than what? Epsilon. Okay. Now, we are going to prove to see if you get an epsilon. Meaning that if I choose my capital N to be equals to 6 over epsilon. So please, that's what I'm saying, that these are properties and theorems we are following. In fact, immediately you get to this place, here, once you get here, you just apply this rule here. Once you apply this rule, the next step is that it's less than epsilon, and you will choose the epsilon. Okay, so if like I have here 1 over n, it will be, we choose capital N to be 1 over epsilon. If I have here 3 over n, then I'll choose capital N as well, 3 over epsilon. That's how you do. So wherever I see n, I'm going to put epsilon there to see if I'll get something like that. So I'm going to have 6 over 6 over epsilon. And when we do that, we are going to have 6 divided by 6 over epsilon, which will be 6 equals, you need to prove and get epsilon. Okay, epsilon over 6. So this cancel this, we have epsilon. So that is proven. That is it. So the rest thing is that you have to state this, try to find LCM if it is needed to do so, and you continue. Let's look at the example. Maybe you might get understanding better at the second example. Okay, so now this second example, I've already said that always you will see me with this, because before you're able to solve the question, you need to state this. That is very, very important, and so you have to know it in off head. So you want to prove that, or show that this limit as n approaches infinity of n minus 1 over n plus 2 equals 1. So if you want to do that, you want to prove, okay, using the epsilon. But the question will not even tell you to use epsilon. You have to know, once they say prove, you have to use epsilon. But without bringing equals 1 and you have to work this, it is very easy. Just look at the n, the numerator 1, the highest power there, which is 1. Divide here by 1, n here by n, here by n, here by n. So that way you get the answer. Now, so let's see how we're going to solve this question. So our an is the whole of this one. So we start with saying that n minus 1 over n plus 2 minus L, which is 1. Remember this distance we put there should be less than epsilon. First, you find the LCM. Our LCM is going to be n minus 1. I mean, you go straight to the point. This gives minus n minus 2, all divided by n plus 2. So if you get this side, straight away, this cancel this one. You have negative 1, negative 2, which will give you negative 3 over n plus 2. Here, there's no n for us to divide, just like I was showing first. So straight away, because there's absolute sign, if I take it off, I have positive 3. N plus 2 is still all integers. So once I add 2 integers, I still get n. You say that this one, as we said, should be less than 1 over capital N. Sorry, since here is 3, here 2 should be 3, which should be less than epsilon. So in this case, what we are going to do is that we choose, one capital N to equals to 3 over epsilon. So we're going to have 3 over 3 epsilon. how I saw the first one, you could see that this one you get epsilon. Is that okay? So per that we can see that 3 over n is less than what epsilon. This is what we just want to prove. Let me go through. Let me write it there. So proving. Thank you. Now let's solve another example. It's like, so people are saying like, how? How? Yes, that is how it is. It's rules, so you should obey it. Thank you. Now let's look at the last example. So my rule is there. So you're going to do this first. The whole of this is our a and this is our l. So we substitute straight away. So we're going to have 6n squared minus 3n plus 1, or divided by 3n squared plus 4n plus 7 minus our L, which is 2, should always be less than epsilon. So that's what you are going to say. First find LCM. So we multiply this one by this, or divided by this. That's straight away. So we go straight to the point saying that 6n squared minus 3n plus 1. This multiplied by this straight away, negative 2 times this, that will give you negative 6n squared minus 8n minus 14, or divided by 3n squared plus 4n plus 7. Straight away, like this. So straight away, you realize that as you go with this, minus 3n minus 8n gives you minus 11n. So we're going to have minus 11n. 4, 1 minus 14 is minus 13. And you remember this is divided by this side, 3n squared plus 4n plus 7. This is what you have. You always have, so you divide through by n because of this. This is power 1, so you divide through by n. If it is power 2, you divide through by 2. So let's go straight to the point. If you do that, if I factorize negative out, you remember it's absolute, so it will take care of it. If you do that, you're going to have, if I divide through by this, I'm going to have negative 11. But because we are in absolute, you can write it positive. Here too, the same because of the absolute. If you take it one after the other, factor is negative, and that's how positive over n. If I do this one I'm going to have 3n. Yes, and this one will give me 4 plus 7 over n. Remember that. This is beautiful because after all, what we are going to get here, these ones are n is approaching infinity. So when I put it there, everything will go to 0, because when you have 7 over a bigger number, everything there goes to 0. This one can never go to 0, because when I multiply 3 by a bigger number, I'll still get a bigger number. And if I add this one to this, they are all integers, so they will all be the same thing. So I just maintain as 3. So this also goes to 0. So at the end, I'm having 11. Let me take it from the absolute, because they are all positive now. 3n. You say that this one should also be less than 11 over 3 capital N, which should be less than what? Actually. So you choose our H our capital N to be equals. Now look at this. You are going to choose our epsilon to be our N to be 11 over 3 epsilon. So you see how the epsilon is being chosen. I mean the N is being chosen, depending on whatever that is here. That's how we take it as it. So let's move on to this place. Let me bring it here. So let's go back to this place to see if you can get the echelon. So you have 11 over 3, bracket open, 11 over 3 echelon, like this. Remember this will cancel this, leaving 11 over 11 over echelon, which is the same as echelon. Proved. So you just say therefore this is equal to that. That is very easy, just that you have to follow the rules. You don't need to understand much things here. It's a property.